Hello, welcome to the video. In this video, we will discuss about the LED blink program using assembly language program of 8051 microcontroller. Now, this program is very much similar to the previous program what we saw about the uh, software delay. The same program, just there is one small change, that is we have included a port here. So rest all is same. You can watch the previous session for complete detail of this program, how the delay is calculated, what are these values written here, how many times each instruction is getting executed. All that you can check it out there. Now here, what we have to understand is CPL instruction is a bit operator, bitwise instruction. So that is complement. So that is going to change the state of this bit every delay. So now what happens? We call a delay, then we complement the bit. Then again, this will be under continuous loop. This is an infinite loop. Every time it will call the delay. After delay, the status of this particular pin number will be reversed. That is, if it is 0, it becomes 1. If it is 1, it becomes 0. So to access any pin number, we use a dot. Port 1 dot pin number. Now we know that all the ports are bit addressable, but only in the SFR there are certain registers which are bit addressable. So all those registers are accessed in the same way. That is the name of the register what we want to access. Then with the dot operator and bit of that register. That is how we access the bit numbers or the pins. Now if I compile this code, let me build this. We can see that it's generating a hex file here. I hope you remember how to create a hex file. All you have to do is just right click here, go to options, and then you have to go to this output tab and enable this. When you create a project, this will be disabled. So we have to enable this and make sure that the microcontroller what you have selected is correct, because we want to simulate this on the Proteus. So we should have exactly the same microcontroller selected in both the tools. Then click OK. Now we have compiled it successfully. Now if I go to debug mode, we can see here the port 1. If you don't know, go to peripherals, IO, and select the port. Now if I run this code, you can see that that particular bit is complemented or it is blinking. Okay, so our program is executed successfully. Now we will run the same code on the Proteus. Now this is a Proteus circuit. So we have selected the same microcontroller as what we have created a project. Then this is a clock circuit. So you're connecting a crystal and two capacitor of 32 picofarad. One end of capacitor is connected to ground, another end is connected to clock circuit or the crystal. Then we are connecting that to external and external 2 of microcontroller. So pin number 1.0 or 1.0 is connected to an LED. So if you see the LED what I have connected is in such a way that whenever this bit is 0, the LED will glow. So here I have connected a power supply with the 5 volts. Okay. Again, in the previous sessions, I have explained how to create a project in the Proteus and how to do all the connections. That also I have shown that. You can see that video. Now, one thing you should know that every time you want to execute or you want to change the program, you double click here. We browse the hex file from here and we load the respective hex file. Now already I have loaded the hex file. So I'll just run the code. So here is the option to run the code. Now if I run the code, now the LED starts blinking. Now depending on what delay we have given, accordingly the LED will blink. If I reverse the LED, then the blinking will be on the active high condition. That is when pin is high, that will blink. Now it is active low because you can see that anode have connected to power supply and cathode have connected to pin. So this is working as an active low LED. Whenever this bit is 0, that is when the LED is blinking. Okay, rest all how to add the components are all we have seen that. Only thing you should careful that the microcontroller what to select should be same and the both the tools. Thank you. Hello, welcome to the video.